All right, today we're going to go over your Unit 1 practice test number 3 review. Here are the answers. I'm just going to kind of work through them with you. So the first one, again, just like all the other ones we've been doing, this is going to be very similar to your test. You'll notice that this review number 3 is shorter. This is going to be more similar to what you're actually going to see on your test Monday. So the first thing says, given that f of x is 6x minus 5 and g of x is 3x squared minus 4x plus 1. So those are the two different functions, and now we're going to do some problems. Number 1 says find what would f of x minus g of x. So notice we've substituted what f of x is, 6x minus 5. We've put that here for the f of x. Then we're going to subtract this whole g of x, so it's minus with parentheses around all of your g of x. Because you are subtracting every single thing that's in that parenthesis, so this is subtracting a 3x squared. So notice it says minus 3x squared. You're distributing that negative sign in. Negative negative becomes a positive 4x. A negative positive becomes a negative 1. Then we're going to combine our like terms. There are no other x squared, so this negative 3x squared comes down. You have a 6x and a positive 4x, so together that gives you 10x. Then you have a negative 5 with a negative 1, which gives you negative 6, and that's your final answer. Number 2, we're multiplying. So you're taking, again, the 6x minus 5, which is your f of x, and you're taking the 3x squared minus 4x plus 1, which is your g of x, and we're multiplying. So we're going to distribute that 6x, and we're going to multiply 6x by all three parts here. Then we're going to take the negative 5 and distribute it by all three terms. So 6x times 3x squared is where the 18x cubed comes from. 6x times negative 4x is where your negative 24x squared comes from. And 6x times 1 is where your 6x comes from. Now negative 5 times 3x squared, negative 15x squared. Negative 5 times negative 4x is a positive 20x. And negative 5 with a positive 1 would be a negative 5. Now that we've taken care of all the parentheses, we're going to distribute. Here's a x cubed. There are no other x cubed, so 18x cubed comes down. You do have 2x squareds and a negative 24 and a negative 15. Signs are the same. Keep that sign. Add the numbers. So that's where 24 and 15, that's where negative 39 comes from. X squareds. Then we had some x's, a 6 and a 20. Both signs are positive. Keep the sign, add the numbers, so 26x. And then the only constant is that negative 5. Number 3 is actually having you evaluate. So you're going to put a 3 in for this x. So you're going to put a 3 in where you see this x. So when you write 6x minus 5, you're going to write 6x minus 5. You're going to replace that x with that 3. Plus, now we're going to take this g of x. And instead of an x in here, we're going to replace it with a negative 2. So notice how you had 3x squared, 3x squared, x is negative 2, minus 4x, so minus 4x is this negative 2, and then a plus 1. Wherever you saw an x here in the g of x, you replaced it with that negative 2. Then we're just going to simplify, evaluate, compute this, and figure out what the answer is. So 6 times 3, because we always do multiplication before we would subtract, that would be 18 minus 5, which is 13, plus sign. We do our exponents first, so this is going to be a negative 2 times a negative 2, which is a 4. So then that's going to be 3 times 4, which would be a 12. I've got another multiplication going on here, so that's going to be a negative 4 and a negative 2 would be a positive 8. And then this plus 1. And 12 plus 8 is 20, and 20 plus 1 gives you that 21. And then finally, adding your 13 from this part to your 21 from this part gives you a combined 34 for your answer. Number 4 is doing a piecewise equation. So again, your f of x is going to change depending on what the x value is. When your x's are less than or equal to 1, we're going to use this equation that's in yellow. If your x is greater than 1, then we're going to use this green or teal, whatever color that is. So when they want you to find f of negative 3 plus f of 2, you need to first figure out which equation are you going to use for f of negative 3. So is negative 3 less than or equal to 1? Yes. Then we're going to use this equation. So I'm going to say x squared. Remember your x is negative 3. So x squared minus 8 comes from right here. You can work that out if you want to, or we can just go ahead and finish up the rest of this problem and then simplify. It says plus, now f of 2. Is 2 less than 1? No, then we're not going to use that equation. Is 2 greater than 1? Yes, we're going to use this equation. So when your f of 2, when f of 2 is going to equal this because 2 is greater than 1. So I'm going to use this negative 2, absolute value, 3 times that x, remember your x is 2, plus 1, close your absolute values, and now we're set up and we can work this. So a negative 3 times a negative 3 would be 9, and 9 minus 8 is where the 1 comes from. Absolute value, group this part first. You're multiplying, so this is going to be 6 plus 1, which is 7. The absolute value of a positive 7 is 7. And that negative 2 times positive 7 would be a negative 14. And then add your first part here, 1, to your second part, negative 14. And 1 plus negative 14 would be a negative 13. Remember, if the signs are different, you keep the sign of the larger number and take the little one away from the big one. So 14 minus 1 is why it's 13, and it's negative because 14 was the bigger number and it was negative. You had more negatives there. So your answer remains negative. All right, the bottom two here, we're factoring. These are numbers that are even or powers of 2. So this is going to be that difference of perfect squares, where this one over here is going to be that SOAP one, which is the cubes, because these are multiples of 3. So you take the square root of both. The square root of 4 is 2. The square root of x to the 6 is x to the 3rd, right? Because x times x times x multiplied by another x times x times x, that would be x to the 6th power. So it's x to the 3rd squared. So that's the square root of the first part. Square root of 25 is 5. Square root of y to the 4th would again take it half of it, because that would be y times y multiplied by itself would give you y to the 4th. So now that you know what the two pieces are, we put each one of those in the parentheses. The first one goes first, the second one goes second, and then they had good times and bad times. We've got one of each sign, a positive and a negative. I always go back and check my negative to make sure that these are not perfect squares. They're not, so you're finished. Number 6, that's the one, because these are cubes, we're going to take the cube root. So what number multiplied by itself 3 times would be 8? So 2 times 2 times 2. And then y to the 6th power, taking the cube root of that, you're going to really divide through by 3, because you're grouping it up into 3's. So that's going to be y squared, y squared, y squared. The cube root of 27 is going to be 3, because 3 times 3 times 3 is 27. And the cube root of x cubed is x, because x times x times x is x cubed. This pattern says put each one of those in the first set of little parentheses that we have. Then remember how we square the first, put him first, square the last, put him last, smash them in the middle, which means multiply those two things together, and then we got our hands all messy, and we got to clean our hands with soap. S, same sign. O, opposite sign. AP, always positive. So when you clean that up, you end up with, this just drops down, 2y squared minus 3x. 2 times 2 is 4, y squared times y squared is y to the 4th. That's where the 4y to the 4th comes from. Multiplying your 3 times 2 is 6, x with x times y squared is xy squared, and then 3x times 3x is 9x squared. And remember, we already did the signs. Same sign, opposite sign, always positive. That was the first page. And then the next group of questions, we're going back to multiplying. And there is a quick little identity pattern that you might have memorized that we can use, or you always can just multiply it out. So if you recognize that this was actually the same stuff with a plus and a minus sign, then you would know that that was the difference of perfect squares, so it would just be just squaring them would be a 25x squared and a 49y squared. But if you can't see that, it's okay. Just multiply. 5x times 5x and get 25x squared. 5x times 7y and get 35xy. Negative 7y times 5x, negative 35xy, and a negative 7y times a positive 7y is a negative 49y squared. These two cancel, and you're left with the same answer we got. Same argument could be made over here. So there's a pattern where you can square the first part, square the last part, and then you actually are going to double the product inside. So that's this pattern here. Or just multiply. 3x times 3x is 9x squared. 3x times 1 is 3x. 1 times 3x is 3x. And 1 times 1 is 1. So combining these, that's where the 6x comes from. Just please make sure that if you think you're going to multiply this out, this is not 9x squared plus 1. You have to have that 6x there. You have to have this part, or else it doesn't work. So when you're given something that says, like this question, 3x plus 1 quantity squared, go ahead and write it out twice so that you can then multiply it to check your answer if you needed to. All right, then there are 2 problems left, and those are on the division. So the first thing that I want to do here is make sure, because this says long division, you must use long division. On the test, if it says use long division, you must. If it says use synthetic division, you must. And you've got to show me the work. So I need to make sure everything is here and it's in descending order. So 3, 2, 1, none, we're good to go. 2, 1, none, we're good to go. So I don't need to put any placeholders in. Notice how this part right here is being divided by the 2x squared. So the 2x squared is what goes in front, and this is what goes under the box. So then we ask ourselves, okay, what do I have to multiply 2x squared by to get 4x cubed? Or what is 4x cubed divided by 2x squared? So either way you think about that, the 4 divided by 2 would be 2, and x cubed divided by x squared would be x. So we're going to put that answer up here, and now, because you were just focused on these 2 things, but now that 2x is actually multiplying by all 3 of these parts. So you're going to say 2x times 2x squared and get 4x cubed, 2x times negative 3 and get negative 6x squared, 2x times 1 and get a positive 2x. We draw our line and we subtract, but remember, you're subtracting all of those numbers, so really you're changing all of those signs. We're adding the opposite, so this is going to become a negative, this becomes a positive, and this becomes a negative. So a 4x cubed minus the same 4x cubed drops out. Gone. A negative 2x squared with a positive 6x squared, that's going to be 6 minus 2. That's a positive 4x squared. Positive 2x, negative 2x, they cancel out. I'm going to put the 0 in there as a placeholder, and then I'm going to bring down that negative 6. Notice that I didn't change that sign because it wasn't in the parentheses. That's something that just comes down on its own. Then we start all over again. What is 4x squared divided by 2x squared? Or what do you have to multiply 2x squared by to get 4x squared? Either method works. I'm going to say 2. So that 2 times this 2x squared is where I get 4x squared. That 2 times negative 3x is where I get a negative 6x. And that 2 times that 1 is where I get my positive 2. Draw my line, subtract, but we don't subtract, we add the opposite sign. So negative becomes positive, positive becomes negative. These two cancel out. 0 plus 6 is a positive 6x. Negative 6 minus 2 is a negative 8. Okay, once this exponent is smaller than what you're dividing by, you stop. This guy is your remainder. So our answer is, what did you have up here? Your quotient. Always plus, then the fraction. What do we have here? 6x minus 8 over what you were dividing by goes on the bottom. And the last one is using synthetic division. The first thing you have to decide is, can you do synthetic division? Are you dividing by x by itself, x plus or x minus a number? This cannot have an exponent. It cannot have a coefficient. It has to be the letter x, a letter, so usually x, either x plus or x minus a number. Yes, we can do synthetic. So then I'm going to set that equal to 0, which means that my x is negative 1. That's what we're going to divide by. I need to make sure everything is here. 3, 2, there's no 1. So I'm going to rewrite this and put in my placeholder. And then notice these numbers, 3, negative 2, 0, and 8. That's your remainder. So here we go. If this was not here, the very first thing that we do for synthetic division is we come straight down. So I'm going to bring down a 3. That's the first thing I did. Then I say negative 1 times 3. I put my answer up here, my little disco dance, and I add straight down. Multiply on the diagonal, add straight down. Well, negative 2 and negative 3 is a negative 5. Multiply, negative 1 times negative 5 is a positive 5. Add straight down gives you a 5. Multiply on the diagonal, put it up here, and 8 minus 5 is a 3. This will always be your remainder, followed by the constant, and then we work our way up with exponents. Plain old x to the 1 power, x to the 2nd power. So there's nothing left. We're done. This is your answer, 3x squared minus 5x plus 5. Then always remember your remainder. It's going to be plus a fraction. Put the sign in the number that we have right here, positive 3. And then what were you dividing by? Originally, you were dividing by x plus 1. You're putting the x's back in, so you have to put the x back in. All right, y'all. Good luck on your test Monday. I'll see you Monday. Bye.